Okay, class, welcome to our second lesson of applications of exponential and logarithmic functions. So you want to go to page 241 to start this lesson. There's several applications we're going to make throughout this chapter, and the first one, once we've learned how to generally solve exponential equations, is to apply it in finance. So if you took finance with me, you will have seen these two interest formulas. So if I just read this first one, it says investing money. If you deposit money in a financial institution such as a bank, you are in fact lending money to the bank. In exchange, the bank pays you interest. There are two types of interest, simple interest and compound. So simple interest is a very basic equation. You simply earn interest on what you invest, and that's it. So, meaning, if you invest $500, which earns interest at a rate of 6% per year, how much interest would you earn in 1 year? Well, we would go 0.06, and we would multiply that by 500, and you would discover that that's 30 bucks. So you would earn $30 interest if you invested $500 for a year. In half a year, you would just take the 500 times the 0.06, cut it in half, and you get $15. Similarly, in a month, you would just take your 30 if you want to and divide it by 12, and you get $250. Okay. No extra interest being earned. And it says if R is the annual interest rate expressed as a decimal and $P is the initial investment, how much interest would you earn in 1 year, half a year, and 2 years? So basically what you do, we could skip all this and just say, okay, the amount of interest you're going to earn, which is why they give you this formula, the interest you earn is going to be the principal that you invest times the rate of interest times the time. That's called simple. Here are those things again. I is the interest that you earn only. So the simple interest formula only gives you the interest. If you wanted to know the total amount accumulated with simple interest, you would have to take your interest and add it back to the amount that you invested. So when it says Millie invests, there should not be the word in there, to cross it off. Millie invests $23.50 at 7% per year, but only for 6 months. So calculate after 6 months what she gets. So we go I equals, so the interest she's going to earn is going to be the amount invested, the $23.50, that's your P, or your principal. At 7%, we're going to times it by 0.07, and we're going to times it for half a year. And when we do that, we get $82.25. So pretty basic, pretty standard. That's not really where we're going. I just want you to know the difference. Now it says, what is the value of her investment? So here's where we have to say, okay, well, then we would take the original amount that she put in there, and then we would add the interest to it now that we've accrued some, and we would come up with a total of $24.3225. So that's how much her actual investment is now worth in total, all right? Okay, where we're really going with this is the fact that compound interest is much better when it comes to having more money at the end. It says in simple interest, the principal at the beginning of the second year would be the same as the principal at the beginning of the first year. In compound interest, the interest during that first year gets added to the principal, and it becomes a new principal that you start off with again. To understand the comparison between simple interest and compound interest, do the investigation on the next page. I'm not going to go through it all. It takes a long time. What you do learn is that when you do this simple interest thing, you keep doing the original amount that you had, and you add interest to it. But when you do compound interest, you add interest to interest. Well, I can show this, I guess. Okay, the simple interest each year is 9% of 5,000, which is $450. Okay, so I add that on, and that is the amount that she's going to earn every year. So if I just keep adding $450 every year, these are my numbers. Oops, I missed one. So you see, every year, we just add on the interest, the 9% of 5,000. We add that on every year. So the value at the end of 8 years, the interest that she's earned, the $8,600 that her value, that her investment is worth, she put $5,000 in to start, so she has earned, the interest that she's earned is actually $3,600, right? Just the 86 minus the 5,000, and her value of the whole thing, the value of everything combined, is now $8,600. Okay, what if we did compound? So what if we found the interest and we added on to the principal at the end of year 1, and then we found the interest on that? So to do that, we're going to take the principal and we're going to add on the interest. So the interest that we do the first time is exactly the same, the 5,000 times the 0.09. Now, that would be 5,000 plus 450, correct? Now, if you want to come up with the equation for this, we take the 5,000 and we factor it out, and that is important. So really 5,000 times 1.09. Think of the 1 as being the original amount that you had, and the 0.09 as being the extra that you're going to get with the interest. And so when you do that 5,000 times 1.09, you'll come up with the 5,450. But now, going into year 2, this is the new amount because we add on the interest from the previous year to the initial amount. So that's here. And then we go find the interest again. So we take this original amount, which is here, and we times it by 0.09 again. And as you see what happens, this is the important part. So at the end of 2 years, you have times it by 1.09 twice. Okay, so 1.09, it happens, this part is for the first year, and then we times it by that 1.09 again the second year. And so by the time you're done, at the end of 3 years, you will have $5,000 times 1, which is the initial amount, the 9% that she received each year. And when you do the table on the next page, I'm going to give you a formula for this. This is just how you would discover it if you cared. On the next page, this number, I can just show you how this grows. Okay, this is 5, 9. And it grows quite a bit. Well, at first it's not a lot faster, but it begins to grow faster the longer you leave it in. And it's going to go all the way down, and at the end we're going to have $9,962.81. It's just going to keep going, and your final formula is 5,000 times 1.09 to the end. This will be 5,000 times 1.09 to the 8. And if I wanted to fill the whole chart in, you'd see how it worked. Okay, so if I wanted to show this on a picture, on a graph, I'm not going to put all the data in, but simple interest is going to go in a linear line. So simple interest is going to look approximately, it finished right about here at 8 years, right about here. So simple interest went like this. And our compound interest, it starts going close, but by the time we're done, at 8 years, we were at almost $10,000. So on this 8, we're almost up here. But it starts quite similar, but then it starts to grow. And that's the benefit, and that's a curved line, it's a little bit of a curved line. That's the benefit of compound interest. Because you're earning interest on interest, the farther you go on, the quicker that begins to grow. There's a little equation given to you here. You've seen that before. And if we were going to write this in here, this is the number you've seen before. That's the initial amount. This is your growth rate. And this is how many times it happens. All right. So on the next page, there's your formula for it. Compound interest is the one. So in the previous explorations, interest is compounded on an annual basis. But in practice, compounding can take place over any period of time. You can compound it semi-annually, monthly, daily, or continuously, etc. So what is super important to learn about this is that this little n is not the number of years. It is the number of times or the number of compounding periods it happens. So I'll show you some examples of that, but that is the key to this. That's what you do not want to get wrong. P is the principal, A is the final amount, different than simple interest. The simple interest formula I gave you this, and I is only the interest. But in this formula, A will be your accumulated amount. How do we spell that? That's your final amount. Like if you want to know how much it's actually worth, that's what the A gives you. Okay, so if I actually want to know this interest in the compound formula, I'll have to do some subtraction when I'm done. Okay, so that's the major difference here. P is the initial amount that you put in, or the principal. I is the rate of interest, and N is the number of compounding periods. Note that I represents the interest rate per compounding period. So if you had 12% compounded annually, but we're going to do this every 6 months, then you only get 6% the first half of the year and 6% the second half of the year. So we do have to compensate, and that's what this guide is telling you. He always has something really important to say. Note that I does not always represent the annual interest rate, and N does not always represent the number of years. We have to be critical in our thinking and check it out. Okay, here's the example. $1,000 is invested for 5 years at an annual interest rate of 6%. Complete the table to calculate it. So the number of compounding periods, we can do this. Semi-annually means twice a year, quarterly is 4, and monthly is 12. So if we're going to do this for 5 years, if we did it annually, it would happen 5 times. Semi-annually would be twice every year, which means it's going to happen 10 times. Quarterly would be 4 times every year for 5 years, which would be 20. And 12 times for 5 years would be 60 times. So you're going to compound that interest 60 different times if you do it annually. Okay, now the interest rate, this 6% gets split. You only get 6% for the entire year. So if we're only doing it once, we get 0.06. But if we're doing it twice a year, we're going to take that 0.06, we've got to cut it into 2 parts, which gives us 3% each compounding period, and etc. We would go all the way down. So this 0.06, we're going to cut it into 4 parts, because we're going to do this 4 times in the year, which is 0.015. And if we were doing it monthly, we're going to get a lot of little amounts of interest, and it's going to be 0.005. All right, so how does that affect our formula? So our formula is going to be our P, which is our initial investment, $1,000, times, times 1 plus our interest rate per compounding period, which in this case is 0.06, raised to however many times it's however many compounding periods we have. So once a year for 5 years. When we do it semi-annually, we're going to have that same $1,000, but this time the interest rate we're getting each time is 0.03, and we're going to do it 10 times. So the number of compounding periods is the exponent, and this would be 1, you get the point, okay? This last one would be $1,000 times 1 point. Can I just add them together? 1.005 if I add those two together, and then to the 60th power. Okay, so if you want to see the difference, if we actually did these amounts, here's the answers that you would get should you do the math. Now make sure you add those together, raise it to the power first, and then times it by 1,000. Follow your bed math there. So these are the amounts that we would get should we actually do the calculations. So you'll be able to see a little bit how compounding it more often gives you a little bit more money. And of course, the more money and the longer you do this, the more it increases. So compounding it monthly in just 1 year gives you about $10 difference. Not a huge amount, but like I said, the longer you leave this in this account or the more money you put in, the bigger that number changes. Okay, let's do some examples. So $7,000 is invested in this 6-year GIC compounded quarterly at a rate of 5%. If you could get 5% on a GIC, GIC stands for Guaranteed Investment Certificate. That means the bank will guarantee you your interest. 5% is very high. Right now, you would come close to getting that guaranteed, but that's okay, we can do the question. To determine the value of the investment at the end. So they just want to know all this information. So the first thing I look at is $7,000 is your P. The interest that you're getting is 0.05, but notice it's compounded quarterly. So I'm not going to get 5% every time. I'm going to get 5% spread out over the year. Per annum, annum means year, okay, per year. Annum from the word annual comes from the same root word. Okay, we're going to do this quarterly, so we're going to go 0.05, and then we're going to divide that by 4, which is going to give us 0.0125. And the number of times this is going to happen? Well, 6 years, compounded quarterly, that's 24 times. Yeah? So here we go. It goes A equals 7,000 times 1, and we're going to add the interest rate to it because it's 1 plus I, so 1.0125, and that's going to happen 24 times. Make sure you put your 1.0125 into your calculator first, raise it to the 24th power, then times it by 7,000, and you will get your investment is worth $9,431.46. Okay, that's the total investment. How much was the interest actually that was earned? Well, that would be the difference between the two. So $2,400.31, or $2,431.46 for the actual interest that was earned, but that is the $9,000 is the amount that her investment is worth. Okay, turn the page. Okay, Christine invested $2,500, that's your P, for 4 years compounded semi-annually, that means twice a year, and received $843.26 in interest. What was the annual interest rate? So this is what I don't know right now. It's a question mark, not a two. Do I know the number of periods? Yeah, I do, because it was 4 years compounded semi-annually, so I know this is 8. I don't know I, so I must know A, the final amount. And the answer is, yeah, you do, because she had the $2,500 that she invested plus her interest. So you have to add those two together to come up with the accumulated amount that she had. So when I plug this into my formula, it's no problem. I go like this. Here's your original formula. Or I think they use I instead of R. 1 plus I to the n. Okay, I'm going to put in my numbers in. So when I add those together, I get 3343.26 for my A, my accumulated amount right here. And my principal that I invested was $2,500. I don't know my interest rate. I know it happened 8 times. All right. Here comes our algebra. We're going to divide up the 2,500 on both sides. We'll get, now, that's going to cancel this. This is to the 8th power. So how do I get rid of that 8th power? Well, we can raise this to the power of 1 over 8, or you could take the 8th root. Either way. So when I get that, I'm going to get 1 plus I equals, if I do this division here, and I take it to the 1/8, or take the 8th root of it, I will get 1.037. Subtract the 1, and I alone actually equals the 0.037. So, but that was the inch, that's what's going in right here. And what was happening to that? It was happening semi-annually. So actually I need to times this by 2 to get the annual interest rate. Because what's the annual rate? So I times that by 2 and it becomes 0.074, which is 7.4% if I want to give it as a percent. Okay, so that's what your answer is going to be there. All right. 2 more examples and we're done. Barbara invests $8,000 in an account. Perfect. Let's put that $8,000 right there. It pays compound interest of 6% per annum or per year, compounded monthly. So I know right away I'm going to go 0.06 and I'm going to divide that by 12 because it happens monthly. How long would it take? Ooh, this is my question. How long would it take in years and months for her investment to double in value? So if it doubled in value, that means my final amount is going to be $16,000. Plug into your formula and away you go. So it's going to look like this. A equals P times 1 plus I to the n. So we plug it all in. Right quickly. I know this is 0.06 divided by 12, which on my calculator is 0.005. So I'm just going to make that 1.005. I don't know how long it is to the nth power. All right, so now I'm going to go ahead and divide by my 8,000. Which makes it a 2. Oh, wow. What do I do now? You could plug in numbers to guess and check. It would take you a long time to do that. You could figure it out, or you could turn this into logarithm. Every time you are looking for an exponent, you can turn it into logarithmic form. And if you do that, you can make this be a base is always a base. So this is going to be the log of the base is 1.005. The exponent goes over here, because remember a logarithm is or equals the exponent. And the 2 is the argument. So we have base to the exponent equals the other stuff, which is what I have here. Base to the exponent equals the argument. So now you just type in log. If you have a base thing on your calculator, you can type that in. Log base of 1.005 to the 2. Or if you don't have that function on your calculator, you can do this. And you can find out what n is. N is going to be 139 when you're all said and done. So we have 139. Now that is not years. That is the number of times it is compounded. So go back and look and see what it asks you for. It says, how long would it take in years and months to double in value? So it doesn't want the number of compounding periods. You actually have to take that 139 times. It's happening every month, right? It's compounded monthly. So you want to divide that by 12 and see how many times 12 goes into 139 times evenly. When you do that, you get 11 years. There's a few left over. So figure out how many months that is. You should get 11 years and 7 months. All right. Good. Okay. Now, sometimes you borrow money. When an amount of money is borrowed, interest is charged. Okay, I just wanted to quickly show you how I did that 11 years and 7 months. When you take 139 and you divide by 12, before I go on, you get 11 points. So when I do this, I'll get 11.5833333. So this part is your years. You take this amount and times that by 12 to see how many months you actually get. So when I times that number by 12, I get 6.99999, which is where my 7 comes from. Just wanted to mention that real quick in case that was confusing. Okay, so take 109 divided by 12, take the excess and times it by 12 to see how many months you have. Okay, now, sometimes you borrow money. This Andrea is borrowing $7,500 from her parents to buy a new car. Her parents are going to charge her interest at a rate of 4%. PA stands for per annum, compounded quarterly. That means 4 times in a year. When she pays off the loan, she has to pay $785 in interest. What was the length of the loan? So we have to fill in this. So what is the actual amount that she's going to have to pay back? Well, $7,500 plus her $785 leaves her going to have to pay $8,285 back. Okay, what was the P? Well, that's the initial amount that she borrowed. The 1 plus, what's the I? Well, 4% compounded quarterly is going to be 0.04 divided by, you can actually put it right in here if you want to, divided by 4. And then how many times it's going to be compounded? Well, 4 times every year We don't know how long it's going to be, so we're just going to keep that in our mind. We don't know this. Okay, so you do the math, and when you do this math, you need to be careful. Okay, so we're going to get this. I'm going to divide by 7,500 first to get rid of it. So I'm going to have 8,285 divided by 7,500 equaling 1.01 to the n. And when you do 1.01 to the n, every time you're looking for an exponent, you need to turn it in to logarithm form. Every time you're looking for the exponent, do the log. So when I do the log of this and I turn this into logarithm form, I'm going to have log. The base is always a base. So this is my base, 1.01. This is the exponent. A logarithm always equals the exponent. And this number right here, this 8285, I'm going to figure out what that is. 8285 divided by 7,500 is actually 1.1047 if I round it off slightly. And if I do that on my calculator on your base, you can either do that or you can split it into 1.1047 and divide it by log of 1.01. Okay, so you can do, however, if your calculator has the base, that's easy. And when you do that, you will get the number of compounding years to be 10. It's actually 10 quarters, isn't it? Because it's happening quarterly. So 10 quarters, if I actually want to know how many years it's going to take, what was the length of the loan? I could say 10 quarters, or better yet, if I divided that, 10 quarters divided by 4 is going to give me 2.5 years. Okay, it doesn't actually say it, it says how long, but usually you want to give your answer in years. Okay, hopefully you can follow those examples and do your schoolwork.